Good day everybody. We got an interesting question. So foremost, let me draw the figure. So we got a park which is of the following shape. Okay, so this is A, this is B, this is C. So you have a circle that has been inscribed inside this triangle. Now this is the park. The entire shape is the shape of the park, and imagine that you have the running track. Now we've been given the following measurements. So this is say 250, and this side is say 120 and this side is 170. And figure, let me give you this information. Figure is not to scale, so don't be upset that 250 is so small, right? So this is just a pictorial representation of the park. Now the question wants us to find the area of this region, area of this region, and area of this region. So probably they would like to design or create a small minuscule area for children to play, for seniors to exercise, and so on and so forth, right? So they are interested in finding the area of the shaded region, and we are not given anything else apart from the perimeter, right? Now to get the area of the shaded region, what are we to do? Area of the shaded region is nothing but area of the triangle ABC. From the area of the triangle you subtract the area of the circle, right? But apparently we are not given the area of the circle, except that if I were to connect this point from the center to one of the bases, I know this region is R. That's all I know, right? And similarly we can go on and go forth in connecting the center with the base of the triangle. So this is the explanation for the question, and this is the requirement: find the area of the shaded region. So all these areas need to be calculated. So foremost, what I wish to do is I would like to step 1. This is my step 1. So what I'm going to do, I would like to find the area of the triangle ABC. So for that I would like to utilize the Aaron's formula. Now why am I utilizing Aaron's formula? Because all I've got is the measurement of the sides. First, let me calculate the value for S. I hope you know the Aaron's formula. Area is equal to square root of S into S negative A, S negative B times S negative C. This is the formula, and S is given to be as A plus B plus C divided by 2. From here, if I were to add 250 plus 120 plus 170 divided by 2. So if I were to calculate this, this is going to be 7, 9, 14, 1, 2, 3, 4, 540 divided by 2. That is going to be 270. So the perimeter, I can't say perimeter, I can say half of the perimeter, because perimeter's formula is A plus B plus C, and S is nothing but half of the perimeter, right? So this is going to be 270 meters if all these things are in meters. So I've got the value of S. So now I need to get the area formula. So 270 times 270 minus A. So we need to get the value of each of the sides, right? So you can simply place in these information, right? It doesn't matter which order you're going to place. At the end of the day, all these sides have to be featured, or all these sides have to be subtracted from 270, right? So 270 minus 250, 270 minus 170, 270 minus 120. This is going to be my A. So if I were to obtain this is equal to, first is going to be 270. Now from 270 you subtract 250, that is going to give me 20. Now this, from 270 you subtract 170, that is going to give me 100. From 270 you subtract 120, that's going to give me 150, right? So you need to evaluate this. Let me multiply and see. This is equal to root of 27 times 2 is 54, and you got a 15 there. So 5 4s are 22, 25, 26, 27, 4 1s are 4, 5, 0, 11, 8, 810. This times this is 810. So you got 810 when you multiply the components, but you got a 0 here and 1, 2 zeros here. So 3 zeros, 4 and 5 zeros. So I need to place 5 zeros there. Now if you were to place 5 zeros, 1, 2, 3, 4, 5 zeros. So let me just check. So after multiplying this with this and this, and then a 1, 2, 3, 4, 5 zeros. So I'm going to rewrite this as root of 9 multiplied with 1, 2, 3, 4, 5, 6. So that is going to give me, I've got 6 zeros, so that 6, okay, let me just multiply or represent those 6 zeros in this fashion, right? Can I do that? 100 into 100 into 100, 6 zeros are represented in this fashion. And 81 is represented as 9 squared. Fair enough, right? Now if you want to take the square of these values, square roots of these values, this is going to be root of 9 squared, root of 100, root of 100, root of 100. Root of 9 squared is 9, root of 100 is 10, 10 and 10, which is equal to 9 followed by 0, 0, 0. This is square meters. This is the area, right? So we got the area of the triangle. Now we need to get the area of the square. How are we going to do that? There is a technique for that. Now what I'm going to do is I'm going to divide the triangle into the following parts. 3 parts, right? So I can connect this with this. So I've got this triangle divided into 3 parts. Now in each of these cases the height is actually r units, right? If I were to drop this, this is going to be my r units. If I were to drop a perpendicular, this is going to be r units, right? So if I were to find the area of triangle T1, what is triangle T1? Triangle T1 is nothing but C, let me place O here, COB, right? So triangle T1 is COB. Now what is the area of COB? Can you tell me? Area is nothing but half times base into height. That's a formula I'm going to use. Base times height. Now what is the base? Base is nothing but 170. What is the height? Height is going to be r. So the area of T1, or I should say triangle COB, is found to be as half times 170 times r. So this is T1. Now similarly find what is T2. What is T2? It's going to be half times 120 times r, right? If this is T2. And what is T3? T3 is going to be half times 250 times r. Now what is T1 plus T2 plus T3? But I'm writing down here, T1 plus T2 plus T3 is nothing but triangle, what is it? ABC, right? So what can I say here? Therefore area of T1 plus T2 plus T3 is equal to area of triangle ABC. Fair enough, right? So in place of this I'm going to substitute the sum of all this. So 1 over 2 is common, you take it out, r is common, so you take that r out. So it's going to be 170, 120 and 250 times r is equal to, what is the area of the triangle we found? 9000, right? So when you add up these three things, what do you get? 5, 7, 14, 1, 2, 3, 4 and 5, 540, right? Divided by 2, and you got the r there. So if I were to place the 2 here and the r there, what I can do here, 2 divides, I need some space here, so I'm going to utilize this space here. So I have 540 divided by 2 times r is equal to 9000. So 2 divides here 2 times, 7 times and 0 times. So 9000. So r will be 900 divided by 270. You cancel this. So 3 divides, or 9 divides here 3 times. 9 divides here 100 times. So r is equal to 100 divided by 3. I know this is going to be a fraction, so let me leave it as it is. This is the radius, right? Now having got the radius, I need to obtain the area of the shaded region, right? So that is going to be area of triangle minus area of circle. So triangle is 9000, area of the circle is pi r squared. So I got the pi and I got the r squared there. So we need to subtract one from the other. So this is 9000 minus 1000 pi divided by 9, which is equal to 81000 minus divided by 9. So if I were to take the value of pi as 3.14, then 81000 3 3.14. See, this is 10,000. You multiply 3.14. So 1, 2, so you get 31400. So you subtract 31400 divided by 9. So 810031400060, and then you got a 9 and then 7. You get this 49600 divided by 9. So if you were to divide this by 9, again 9 5s are 45, and then a 1, and then a 1. So approximately 5511 square meters. So this is going to be the area of the shaded regions which is under question. So this is the solution for this question.